So this is my the second video, sorry, because the length of the video was too high, so I cut the video and I'm again starting. So I am continuing the absorption process. In this process, the firstly electron is get excited and get the absorb the energy from the external mean of the source, and this energy either may be in the form of the heat, current, voltage, or the photons or the light. So now this electron will excite from valence band to the conduction band, and at the time period of the 10 to the power minus 8 second, or can say after completion of the 10 to the power minus 8 second, these electron will again want to come back at the valence band, and it will recombine with the holes. And as we know, whenever electron and holes recombine, it generates the energy. It generates the energy either in the form of the h mu or either in the form of the heat. Now, this is the absorption process. Spontaneous. In the spontaneous process, when the electrons moves from valence band to the conduction band, and at the time period of the 10 to the power minus 8 second, it want to come back and recombine with the hole and generate the energy in the form of the h mu. So the generating photonic energy will escape from the all the direction. यहाँ पे ये जो फोटोनिक लाइट जनरेट हो रही है, इसका कोई पर्टिकुलर डायरेक्शन नहीं होगा, ये किसी भी डायरेक्शन से क्या होगी, एमिट होगी. So whenever electron and hole recombine and it generates the photonic energy, and if it is generating in all the direction, so these type of the emission is called the spontaneous emission. यहाँ पे जो फोटोनिक लाइट जनरेट होगी वो किसी भी डायरेक्शन में होगी. इनका कोई पर्टिकुलर डायरेक्शन नहीं होगा. ओके इसीलिए इनकी इंटेंसिटी जो होगी वो बहुत ही कम होगी. एंड दीज टाइप ऑफ द एलईडी सोर्स ऑप्टिकल सोर्सेज इज यूज्ड फॉर द शॉर्ट हॉल कम्युनिकेशन. Here I am introducing the term that is called the short, S-H-O-R-T, short Hall, H-A-U-L communication. And these optical sources is generally known as a light emitting diode. ये बहुत ही cheap होते हैं, सस्ते होते हैं, और इनकी जो लाइट की इंटेंसिटी होती है बहुत ज़्यादा नहीं होती है, कम होती है. इसीलिए इनका जो फैब्रिकेशन होता है वो भी बहुत इजी होता है, और ये बहुत सस्ते आते हैं, और ये स्पॉन्टेनियस इमिशन पे काम करते हैं. एंड वन मोर थिंग, दिस इज refer as a non-coherent optical source. Now there is another terminology, this is called the coherent optical beam, and second one is the non-coherent or uncoherent optical beam. अब ये क्या होता है? What do you know? What do you understand by the coherent optical beam and the non-coherent optical beam? So the answer we can understand by our second process, or this is called the stimulated emission. In the stimulated emission, the same process will happen at the absorption process. The electron will get absorb the energy, and it will move from valence band to the conduction band, and it will reach on the conduction band, and at the time of the 10 to the power minus 8 second, okay, it wanna come back on a valence band. But due to the property of the material, these material have the indirect band gap energies, or can say it have the metastable states. Valence band and conduction band have some intermediate state. It's called the metastable states. Now, at this stage, electron will remain constant, and it will stay for the long time. The coming electron from the conduction band will stay here for the long time. Until and unless if we provide the external photonic energy. Whenever we apply the external photonic energy in the form of the h mu, so these electrons will get some part of the energy, and after absorbing the energy, it will fall down. And now this falling electron will want to get recombined with the hole, and whenever electron and hole get recombined, it generates a photonic energy h mu. Now we have the two photonic energy. The first one we provided at the metastable state, and the second one which is generated by the recombination of the electron and hole at the valence band. Now h mu 1 and h mu 2 so this is the direction of the h mu 1, and this is the direction of the h mu 2. These beam will propagate in a same direction, and it will have the same amplitude, the same frequency, and the same group velocity. And because of this, the intensity of these kind of the optical source is the very higher, and this is called the stimulated emission of the radiation. And generally this type of source is known as a laser, that is the light amplification by the stimulated emission of the radiation. So here are the three processes. The first one is the absorption, where the electron will get excited from the after absorbing the external mean of the heat. It will get excited from valence band to the conduction band. In the second process, in the spontaneous emission, the electron will want to fall back from the conduction band to the valence band after completion of the 10 to the power minus 8 second. Now the electron will get recombined to the hole and generate the energy h mu. In the next process, in the stimulated emission, again the falling electron after completion of the 10 to the power minus 8 second from the conduction band, it will, due to the indirect band gap semiconductors, Okay, these are the direct band gap semiconductors. D direct band gap semiconductors, DBGS. This is called the direct band gap semiconductors. Direct band gaps semiconductors. And these are the indirect band gap semiconductors. Indirect band gap semiconductors. Indirect band gap semiconductors में क्या होगी? Metastable state. So the electron will stay at the metastable state. कब तक रहेगा? For the long time. Until and unless it will have the external energy again. Okay, so after getting the external energy h mu, electron from the metastable state will fall down in the valence band and will recombine and generate the h mu energy. Now this is called the coherent optical source, and that is the laser, and this is called the non-coherent or uncoherent optical source. This is the LED, light emitting diode. These both sources have its individual characteristics and it uses for the different applications. If I want to communicate for a long distance, okay, so I will use the laser beam. If my application is for the only the short path, so I will use the LED. So thank you guys. This is the short description about the absorption, spontaneous emission and the stimulated emission, and in my next lecture I will cover the basic details of the LED and the laser. Thank you.